Enable recording. All right, I see we have 20 people on here already. I'll wait for a little bit longer. I think most people are here already, so we can go start this already, right? Let me quickly just open some of my notes because I had to reboot my computer. Thought it was maybe an issue with my computer, but I don't think that is the case. So please let me open some stuff in a second. All right, so welcome everyone. This is the Advanced Azure Red Team Tech training of the October 2024 batch. This is the first session. So a little bit of background first about Nikhil, who is the creator of this awesome course and the founder of Alta Security. You guys probably already know him. Yeah, he has also created quite a lot of tools on this and shared them on GitHub as well, such as Nishang, Deploy Deception, Race Toolkit, and a lot more, right? Mostly his courses go around Active Directory and Azure security, right? He's talked at a lot of places, DEF CON, Black Hat, BullCon, and so much more, right? So I'm going to be your instructor for this course. So I'm Keanu Nes. You may have seen me on socials already. So this is my Twitter handle. My LinkedIn is over there as well. And on GitHub, you can know me as Redbyte as well. So I'm the creator of GraphSpy as well. So this is an offensive security tool specifically used to attack Microsoft cloud stuff, so Microsoft 365, Entra, and so forth, which is also going to be used during this course later on, right? I mostly specialize in Active Directory security as well, Azure security, and some social engineering as well, right? I got quite a lot of certifications from some other vendors as well, but mostly from Alta Security, of course, and some Microsoft certifications. So about Alta Security, I'm going to go over this quite quickly because we lost some time already. But we have trained more than 30,000 security professionals, right, from over 130 countries with our various courses. So our Red Team Labs platform is what we try to achieve with that is that our courses need to be affordable, easy to access, right? Stable and provide a great user experience. That's not the same for Zoom. So fun to solve. The labs are very fun. So I hope you guys will be enjoying that as well. And is big enough to feel enterprise-like, right? So you're going to see later on that the lab is really enterprise-grade regarding the size of it. And it will even cover some multi-tenant stuff as well, right? So let's quickly go over the course content. We will start by providing some introduction to attack methodologies and the tools, go over the API endpoints of using the Microsoft Graph API, mostly with the Microsoft Graph PowerShell module, the new PowerShell module that will be replacing the AED Graph PowerShell module. And then you will see quite a lot of initial access techniques like device code phishing, illicit consent grant, attacker in the middle, abusing JWT signing, abusing custom claims, abusing GitHub actions and workflows, and go over some reconnaissance there as well, right? Some privilege escalation as well. We will show how you can abuse a FOKI, so family of client IDs, certificate-based authentication, attribute-based access control on several Azure resources. PIM, we'll look at that as well, privileged identity management, tampering with logic apps, authentication cookies, traffic interception, and a lot more, right? Then we will also go over in some lateral movement techniques, which are listed over here. Bypassing defenses, so that will be covered during the majority of the lab as well. We will always see whether we can bypass certain protection mechanisms such as conditional access policies, and we will also show a couple of multi-factor authentication bypasses or avoidances as well that allow you to gain access to accounts protected by MFA as well, right? Privileged identity management and Microsoft Defender for Cloud as well a little bit, because most of the techniques that we will show are quite OPSEC safe and will not trigger many alerts in Defender for Cloud as well. Right. We will also cover a little bit on how you can detect the techniques that we will be using and how you can stop them, useful for the blue team side, right? Using log analysis and the available tools from Microsoft, but also go in depth in conditional access policies you can implement and things like that, right? So the goal of this course, we do expect that you already have a little bit of knowledge about Azure already, right? And Entra ID. So ideally, you would have already done the CARTP course. But if you have not done that, then that is fine as well, as long as you already have worked with Azure and Entra ID in the past. We will go into a little bit of an introduction as well about that, but we will not go too much in depth of that either, right? Because this is expected to be an expert level course, right? So this course is split up in kill chains. There will be 4 kill chains that we will go over. So each of them each of these 4 kill chains are completely individually separate of each other. There are a couple of instances where we need some information from a previous kill chain in a next kill chain, but it is really limited, right? And within these kill chains, these are divided in learning objectives, where we will be able to practice some of the techniques and the material that we cover in the slides here first, right? So we will make a couple of assumptions at some points in time to demonstrate the attack techniques that you want, but most of the time it will be fairly realistic as well, right? But I will mention it if we will be making some assumptions for these lab purposes, right? And also note that not everything will be covered in the slide text that you have received. So please pay attention during the training and the sessions as well. But do note that these will be recorded as well, so you will get access to that as well if you want to go over the topic afterwards, right? So how do you use the course content? You got access to quite a lot of material already. So you have access to the slides, the slide notes, and the lab manual. So these are PDF documents you will find on either OneDrive or Google Drive, which you can access by going to the Azure Advanced.enterprisesecurity.io portal. So in the lab portal, you will be able to download all of the lab material and things like that. There will also be walkthrough videos of all of the learning objectives as well, so all of the labs, if you want to go over that. And the kill chain diagrams and lab diagrams are also very useful. So definitely always refer back to those when you are getting lost in the lab, because that will make it a little bit easier to understand where we are, right? So let me actually share that with you guys. Go to my course material. I will show you the lab. All right, you can already see that. And so if you open a kill chain in Windows or something with a black theme, you'll see that you won't really be able to make much sense of that, right? So what you can do is you can open these in Paint, for instance. And if you do that, you see that you will be able to see it a lot better. And if you want, you can save it as a JPEG file instead of a .png file. And then you will have a white background as well if it is not readable enough for you guys, right? There you go.
Okay.
So this is an example of one of the kill chain diagrams. So the attack diagrams of the first kill chain, where you will see in depth what we will be exploiting to make it a little bit easier to understand and to follow, right? So if you get lost during the lab, it can be a little bit confusing at some point in time. Just refer back to that, and this is also what we will be doing during this session, right? Yeah, little word of caution. Everything that is covered in the lab manual and in the slides is in scope, so you can try to attack that. Everything that is not listed in there is by default out of scope, right? So if you need to ask, it's usually already a sign that it will be out of scope, right? So everything that's covered there, you can attack, but don't use any malicious intent, and yeah, some common sense will get you far enough as well, right? But if we see that you're deliberately trying to interfere with the lab or attempt to break the lab for other students, yeah, then we will have to take some actions, but usually that should not be possible, should not be needed, right? All right. So the tools that we will be mainly using will be the Microsoft Graph PowerShell module. So this is the one that I was referring to previously. So this is the new PowerShell module that is that Microsoft built to in an attempt to replace the previous one, the Azure
Do you have
AD
any vegetable yesterday?
module, right? Because that was using
Have
the
any vegetable yesterday,
deprecated
no?
Azure AD Graph
Gone.
API, right, that they want to retire. So the new Microsoft Graph PowerShell
Good
module
day.
is using completely the Microsoft's Graph API in the
Oh, you had
background,
school lunch.
which
But you have any
Microsoft is
vegetables,
pushing
no?
all developers towards to as well, right? So the old Azure AD PowerShell module
Padera bread.
is a little bit still a little bit more convenient to use, right? Not everyone is
Where is it?
muted, I hear,
Left side or right side?
but let me check.
Yeah.
Can you unmute some, please?
I'll put it there.
You can mute all of you. There we go. That should be better, right? So what was I saying? So the Microsoft Graph PowerShell module, you will see it is not a perfect solution. Microsoft is trying to implement all the features that were in the old Azure AD PowerShell module, but you will see that the Microsoft Graph PowerShell module is a little less convenient to use. So therefore, we will also be referring back to some plain old REST APIs to interact with the MS Graph API directly, where the PowerShell module falls short, right? So that is to interact mostly with Entra ID resources and Microsoft 365 resources. To interact with Azure directly, we will mostly use the Azure PowerShell module. That one is still very convenient to use, right? And some Microsoft portals as well, right? You need to be an expert already to know all the portals. So this is a very useful resource, msportals.io. If you go to that one, you will see that you will get a list of all the portals that are available. So let me show that really quickly in case you don't know this already. So a very useful resource in case you want to know which portals are available. And as you can see, there are quite a lot, right? Okay. And we'll also use some open source PowerShell tools, .NET tools, and C++ tools as well, which will be in the tools folder, right? So a little bit about the lab. So our target is oil corporation. So this is a fictitious oil company that is exploiting oil resources across the globe, right? So in this lab, we are going to take the role of a what you call it, a hacktivist organization that is trying to stop the polluting actions from the big oil company that we want to target, right? So please know that this is just for to make the lab a little bit more fun, right? Obviously, don't go do this in the real world, but during this lab, it is fine to put on your attacker mindset and really try to follow the lab as if you were trying to bring down this organization, right? And put an end to what they are doing, right? So our group is called No More Oil. So it's an organization dedicated to stopping the big oil company, right? So our goal is to compromise the oil corporation. It's a multi-tenant organization, as we will see later on. So we will try to gain initial access to their environment and then pivot further and deeper into their environment until we reach the final end to where we will see what their actual plan was. And if we can expose that, we will be able to stop their plans, right? So once again, the link to the lab material, if you don't already have that, make sure to note that down, right? So overview around the lab environment. So it's, as we said, the old corporation tenants that we will be attacking. But this organization is actually using a multi-tenant environment, right? So we will see over here that we have the old corporation Azure tenant at the left, the blue one. And then we have it split it into 4 parts, right? So from top to bottom, we will see this is kill chain 1, kill chain 2, kill chain 3, and kill chain 4. And in each kill chain, we will probably already do some cross-tenant attacks as well, as you can see over here, right? Let me clear the annotations. All right. So the lab is split up into several kill chains. And in each kill chain, we will go through all the specific tactics that an attacker would go through as well, right? In contrast to some of the other courses where we will pivot from, we will cover all the reconnaissance first and then all the initial access techniques first, and then go over all the enumeration and privilege escalation techniques first. Here we really will start each kill chain from the start, where we will get initial access, do some enumeration and privilege escalation and lateral movement every time. As well as defense evasion that will obviously come back in everything that we do. But instead of having it to cover all the initial access techniques at the start, we will do some initial access technique in kill chain 1. And then move on to some later techniques like privilege escalation and lateral movement, where we will start a new kill chain with new initial access and go from that, right? So that is because we got some feedback about the other courses that it was a little bit hard to follow. So hopefully this way of working will make it a little bit easier to follow, right? All right. So let's start with a little bit introduction about Microsoft Identity Platform. As I said, this is an expert level course, so we will not spend too much time on this introduction, but just in case for the people that would have not gone over the requirements for this course, let's just quickly summarize it, and it's also a good refresher for the other people, right? So the Microsoft Identity Platform is, as it says, a cloud identity service that provides authentication and authorization services, right? So it's the identity providing platform from Microsoft, right? And it is the single source where everything connects to when you want to integrate your application with Microsoft's Entra ID authentication platform. You will be using their them as identity provider. Everything will connect through Microsoft Entra, right? So this platform, as you can see, can be accessed by quite a lot of different types of accounts. We will be mostly focusing on the work or school accounts, which is Microsoft Entra ID or previously Azure AD, right? But it also integrates with personal Microsoft accounts, Azure AD business to client accounts or business to customer accounts, and also external identity providers, right? So everything will connect to the Microsoft Entra endpoints, so the token and authentication endpoints. And this will be your middle piece. That's everything will integrate to. So every application that wants to use Microsoft Entra's identity platform will connect to this for authentication purposes, right? And that will usually mean that they will be implementing some SDK from Microsoft. So this is the Microsoft Authentication Library, which acts as some kind of middleware between your application, for instance, the entra.microsoft.com. It's just an application that's interacting with this library to connect to Microsoft Entra endpoints, right? And it's mainly based on protocols such as OAuth and OAuth2, actually, and OpenID Connect. So we'll be focusing on OAuth2 a little bit as well. So some quick background about OAuth. So this is an open authentication framework. And Microsoft actually implements this to provide authentication towards their identity platform, right? So in OAuth terms, you have several parties. You have your resource server, which is this is the entity that you actually want to get access to, right? So think of this as your actual application that you want to access, right? And the resource owner is the one that will be accessing its resources that are stored on the resource server, right? But in OAuth terms, we don't want our resource server to implement authentication themselves, because we want to use some kind of single sign-on from Microsoft Identity Platform. So our resource server will not do any validation of the credentials of the user. That's where we have the Microsoft Identity Platform for, right? So in OAuth terms, this would be our authorization server, right? So if our resource server wants to access or if our resource owner wants to access the resource server, they would first authenticate towards the authorization server, which is in this case is the Microsoft Identity Platform. And that will then return some kind of tokens. So these are called bearer tokens and are usually JSON Web Tokens, so JWT tokens, which will then be provided to the resource owner. And that can be used to access the resource server, right? So a lot of terminology. We also have the client over there. So this is, you can think of that as your actual application on your workstation. For instance, if you're if we make this concrete with an example, let's say we want to connect to Microsoft Teams, right? So the client in this case would be the Microsoft Teams application on our device, right? So you would connect to that. The resource owner would interact with that, but the client in the background, it doesn't have all your messages, right? So it would need to connect to the Microsoft Teams servers where your messages are hosted. And if you want to send a message, it would go to there. So the servers hosting Microsoft Teams would be the resource server in this case. And the Microsoft Identity Platform is the one that will be providing the access to that, right? Using the bearer tokens that your client will store to interact with the resource server, right? So if all of that makes sense, another way to think of that, and maybe it's a little bit easier to explain over here. So we start with our resource server, a resource owner who is actually tries to sign in, or they open their client on their device, right? And the clients will try to access the resource server, but at the start, it doesn't have any credentials, right? So it will send an authorization request towards the resource owner. So it will ask the user to provide some type of credential material that it can use to confirm its identity, right? So it will provide an authorization grant that the client will then forward back to the authorization server. So recall, in this case, the authorization server will be Azure AD, or the new name is Entra ID, right? So Entra ID knows the credentials of the user, or it will also declare text password, right? But if you send the password to there, it will know that it is valid, and it will return some access tokens in case the user should have access, right? So it will if the authentication is successful, it will return some access tokens, some other tokens as well. We'll go into detail over that. And the client will then store that in some local cache where it will be able to keep using that for further authentications, right? Towards the resource server, right? So once it has this access token, it can send multiple API calls towards the resource server. Each time it will provide the access token to prove that it has access, right? The resource server trusts the authorization server, and it will be able to validate that these access tokens are actually valid and signed by Entra ID. So it will know that all information in the access token, it can trust all that information that is in there. So it will know which user is sending these API calls and things like that, right? And then the resource server will provide access to whatever it is hosting, right? So for instance, in our example, all Microsoft Teams messages will be sent back, for example, right? Okay. Let's continue. So as said, we have a couple types of tokens. One of them was the access token that I already talked about. But we also get some other kinds of tokens. So we get an ID token, an access token, and a refresh token. So the ID token, really, it just contains some basic information about the user. This is not used, or it shouldn't be used actually to perform any authentication or authorization. However, since it does contain some information such as username and sometimes the groups of the user and things like that, some applications will actually also use this for authentication purposes. You can do that. Microsoft doesn't recommend to do that. They recommend to use access tokens for that purpose, right? So access tokens are the tokens that you actually use to access a resource, right? So you send these with every authenticated API request to the resource. And then the resource server will be able to validate your identity, right? However, these access tokens are prone to token replay attacks. So we'll see that later on as well, some type of attacks that we will do on the access tokens, right? Microsoft does struggle quite a lot to manage them securely, and probably most types of applications and other identity providers will have the same kind of issue, right? We will see a little bit more on that later on, right? So these access tokens are valid for the documented time for Microsoft is 1 hour. However, usually it's a little bit random. We don't really know what is actually determining this lifetime, but usually it's around 1 hour to 2 hours sometimes for user access tokens, right? There are some other types of access tokens. For instance, when you authenticate as an application, you will see that in a lot of cases, the access token will be valid for 24 hours, right? And sometimes if you, for instance, have an access token that's using continuous access evaluation, the token will be valid for even longer, right? But that's a different story. That's also covered in the CARTP course. And then lastly, we have the refresh tokens. So refresh tokens, you cannot use them to authenticate towards your resource server. So if you go back one slide. So the refresh token will never be used by the client to authenticate to the resource server, right? But these access tokens, as we said, are only valid for 1 hour, sometimes up to 2 hours, right? So what do you do when that expires, right? You don't want to ask your user to authenticate every hour or every 2 hours with their username and password. That would be very annoying and very bad for the user experience, right? So that's why when you authenticate, Enter ID will also, or just in general, in the OAuth specification, the authorization server will also return a refresh token, right? So that refresh token can then be used to connect back towards the, let me go back one slide, back to the authorization server and request a new access token. Right, so it can use the refresh token also as authorization grant to get a new access token. Primarily on the first authentication, it will be user credentials, so a username and password that will be provided over here. But after that, it will use the refresh token to obtain new access tokens, right? All right. These are valid for quite long. So instead of only 1 hour, these are valid for 90 days, right? So let's maybe dive into that a little bit deeper. So the access tokens are valid for a very limited lifetime, right? So usually 1 to 2 hours, right? And these are bound to one specific user. So one specific user only. Also for one specific resource, right? Note that we are covering this very broadly now in OAuth. These are what OAuth specifies, right? So one user, one specific resource. We will see that Microsoft will differ a little bit from the OAuth specification, but at its core, it should only be valid for one specific resource, right? However, if you are able to seal an access token, you will see that these access tokens can also include multi-factor authentication claims. So when a user uses multi-factor authentication during the authentication process, it will be stored, there will be an MFA claim stored inside of the access token itself. And every time you use that access token, for instance, if there is a conditional access policy on an application that requires you to use it requires you to use multi-factor authentication. Once you have an access token that already has satisfied MFA, you can just keep using that access token, right? And it will keep using the MFA claims, right? The access token by itself cannot be revoked before it expires. So by default, you will not be able to revoke this. So if you steal it, it's very powerful, right? Because even if the user notices that they are being hacked, they can try to reset their password or revoke all its sessions, but the access token will stay valid, right? Because that's what they are used for, right? They are only used for a limited lifetime. But if you steal them and the user resets their password after half an hour, you still have half an hour left that you can access the application or the resource server with that access token, right? So that's quite powerful. However, there is one specific use case where it will not be valid anymore. So that's when you use CAE. So that's continuous access evaluation. So if that is in use, Microsoft will be able to revoke these access tokens or invalidate these access tokens even when they have not expired yet. So that's a very specific use case, but this is not available for all applications, only for certain applications that support this, also only for certain clients application that support this. And there is really no real way to actually start enforcing it. There are some applications that support it, right? But yeah, it's mostly out of your control when an access token will be using that or not, right? All right. Oh. Let's continue to the refresh tokens. So the refresh tokens, these are valid for 90 days by default. So this is something that can be reduced if you want, but the default is 90 days. So if you steal that, yeah, you have access for quite a long time, right? However, it's bound to one specific user as well. And it's not used to authenticate as we covered previously, but it's used to obtain new access tokens, right? And the access token, and what's good to know is that the refresh tokens itself can also be refreshed. And in theory, this can be infinitely refreshed, right, for an additional 90 days. So as long as you don't let the refresh token expire, you can use it to obtain a new refresh token, which will once again be valid for another 90 days, right? However, they can be revoked. So by default, if you reset the password of a user, so if the user resets their own password, or if you force a reset of a password, that's something that will update the refresh token, the start time of when Microsoft will allow you to start using that. There is a specific property that's stored in every user account that will store the lifetime from which point refresh tokens should be valid, right? So if you reset your passwords, then that lifetime will be, date will be updated in that property, and all the refresh tokens that are used after that will not be valid anymore, right? Can also be revoked by revoking all the sessions of the user. So we have a question. Are some difference for validity of refresh tokens used in browser and refresh tokens used in client applications? Are there any differences when you have a refresh token for a client application or for a browser application? So not really. Browser applications will just usually store the refresh token in their session storage as well. However, in a lot of cases, when you integrate an application with Enter ID authentication, what what the applications will do is they will obtain an access token, but then they will just use that access token to obtain a session cookie that's just usable for that specific application, and it will just start using that afterwards, right? So even if the user resets their password, and the refresh tokens are revoked, it can be that these session cookies will be still valid for some longer time, because these will be using some other type of expiry, right? That will depend on the expiry of the session cookies in the browser cache, right? And that will be different for all kinds of applications, right? Password reset does not revoke refresh tokens anymore. I'll look into that. Last time I checked, it was still the case. So thanks for mentioning that. I will look into that. All right, let's continue. So please, if you have any questions or anything, just post it in the Discord in one central location, then everyone can see that and try to answer that as well, right? All right, let's continue. The Microsoft Graph API. So this is the main gateway used to access Microsoft 365 and Entra ID, right? So Entra ID, the previous Azure AD, Microsoft needs to rebrand this for some reason every couple of years. So that's what it's called right now. So the Microsoft Graph API is an application that a first-party Microsoft application that is, allows you to access all kinds of information from Microsoft 365. So, for instance, these entail all your kinds of Office applications, so your emails from Outlook, your Teams messages, right? Your SharePoint files and so forth, but also from Entra ID, so user information, device information, all types of Entra ID resources as well, right? So this is the actual a primary application that Microsoft wants every app developer to use in order to interact with Microsoft 365 and Entra ID, right? So they are doing this as a replacement of the Azure AD Graph API as well. So that one will be revoked as or be end of life at some point in time. They have moved the date at which point it will be completely disabled back a couple of times already. So now I think it's somewhere in 2025 that they will that they said that they will stop using the old Azure AD API. So that's why in this course we will be focusing a lot on the Microsoft Graph API, right? Because this is the quote unquote newer API that Microsoft wants you to use and will be supported for a lot longer, right? So Office, OneDrive, Outlook, Exchange, Teams, and more. And Entra ID information, also some Defender 365 and Intune. You can integrate with all of these kinds of applications through the Microsoft Graph API, right? So it's a single API endpoint, HTTPS graph.microsoft.com, right? So this is what we will be interacting with a little bit later on as well. So the Microsoft Graph PowerShell module, this is basically a simple wrapper around the Microsoft Graph API, right? So it is supposed to make it a little bit easier to interact with the Microsoft Graph API. However, as we will see later on, it is not ideal. Still today, it's still not the best and the most convenient to work with. You will see a lot of the output that it returns will not be correctly formatted in easily accessible PowerShell properties, right? But we will cover it nonetheless, and hopefully they will improve it in the future, right? So yeah, it can be used to interact with all of these Microsoft 365 services as well. It's just simply a wrapper. It exposes some commands to you, some PowerShell commands to you. It will send an API call, sometimes even multiple API calls at once, and then provide you the response, right? So commands in the Microsoft Graph module are auto-generated from the Graph API. And it is used, as we said already, as a replacement for the Azure AD module and the MS Online modules as well. You can install it quite easily on any device using the install-module Microsoft.graph command. And yeah, definitely don't confuse it with the Microsoft Graph CLI. That's a completely different application, of course. So the Microsoft Graph module, the MG module, to authenticate with that, you will see that it will request some kind of consent first, the first time you use it, right? So it is not pre-consented by default, unlike other first-party applications from Microsoft. So this one will require some consent, right? You can use it either with delegated access. So delegated access means that the Microsoft Graph API will basically authenticate on behalf of a user. So it will use the privileges of the user, right? And then it will require user consent, right, for the first time. When you use app-only access, then admin consent is required. So you can also use app-only access where you authenticate as an application, but that will require admin consent, right? So a couple of ways that you can sign into the Microsoft Graph module. So it's just using the same type of structure as the other PowerShell modules that you might know. So connect-mg graph, similarly to connect AZ account and things like that, right? So it's a little bit like that. However, you will see that there are quite a lot of differences as well, right? You can just use connect mg graph and expect it to work. You in the background, it will request specific scopes, and then you will only be able to use the PowerShell commands for which you have your access token has the right scope, right? If that makes sense. So for interactive authentication, you can just provide the dash scopes command parameter and then the all the scopes that you want. So for instance, user.readAll will allow you to interact with user related PowerShell modules or PowerShell commands that use the specific scope, right? So you will see this will already be a high privilege scope, so a high privilege permission. So users will most likely not be able to use that without admin consent, right? You can also authenticate with the device code flow, more on that later on. So if you just add a dash use device code authentication, or just connect with it with an access token itself, right? So let me actually open the student VM again. Give me 2 seconds. All right. All right. So the question is, where can the updated slides according to the ones shown in Zoom be found? It seems the ones in Google Drive are not completely identical. Yes, that's correct. I added a couple of additional slides right before we started to make some things a little bit more clear for you guys. So we will update that later on the Google Drive and the OneDrive as well, so that you will have the same slides that I'm showing over here. However, 99% of these slides will still be the same. It's just some minor differences. And we will also, there will also be an update file over there, so a changelog file over there, which we will update. So you will see every time we make some kind of changes to the presentation, so that you know what changes are being made, right? So that you don't have to compare the whole file again, right? So you will get, we will update that soon after the session. Okay, we are connected over here to the student VM. So I was testing some, I'm playing around with Graspy a little bit. But let's actually improve our font a little bit so that you can see a little bit clearer. There we go. So to interact with the Microsoft Graph module, first we need to authenticate, right? So first thing we always need to do is connect MG Graph, connect MG. Connect MG Graph, come on. Yes, there we go. And we need to provide some scopes, right? So let's first start by using the same scopes that we saw in the PowerShell presentation. So user.read.all. We will see that it will prompt us for an account to select, right? So this is just as an example. Let's just select our attacker user account. So you guys also have access to a student account in the no more oil tenant. So consider this as your attacker tenant, right? That you can use to perform some testing, right? If we sign in over here, you will see that we will need admin approval, right? As I said, the user.read.all permission is already high privilege, right? So we will not be able to do that with low privilege user account. But what we are able to do is the user.read basic all. And if we try that again, you will see that we are connected over here, right? So one thing you may like to do after you're connected is use the get mg context as that, and then you will see which kind of account you are connected to. So student6@nomoral.com, as well as which scopes you have. So there are some default scopes that it will add, such as the OpenID profile user.read, and then we have our user.read basic all command over there, right? Okay. So once we are connected, there are a couple of things that we want to do, that we can do with that. There are quite a lot of commands. If you are feeling lost a little bit, you can use the find mggraph command. So this one will allow you to allow you to find the right PowerShell commands that you want to use, right? And if you want to use, for instance, get mg user, and you want to see which kind of permissions you need for that, you can use that to view the permissions of that command, right? So let's actually do that. You can see all of the permissions that we can use to execute this get mg user commandlet, right? So there are multiple ones that we can use. As we said, user.read all, we could have used that. However, you can see that admin consent would be required for that. So it's very useful to use this command to see, okay, what kind of privileges do you need for what kind of command to execute. But instead, we can use the user.read basic.all, right? Because that one does not require admin consent, right? All right. You can use some other types of authentication as well to connect with the Microsoft Graph PowerShell commandlet as an application. For instance, applications will usually sign in using certificates. So if you are able to steal an application certificate, which we will do later on, you will see that you will be able to use that certificate to connect to the Microsoft Graph API, right? You can also use client secrets. So that's basically like using a username and passwords, but then with an application, right? Similarly, like you can do with the other PowerShell modules from Microsoft, right? So for that, you need to first pass a PS credential object. So you can create that with the get credential command, for instance, and then you provide the PS credential object over there and the tenant ID, and you will be connected as an application, right? Or you can connect as a managed identity, for instance, and then you just select, provide the dash identity flag, for instance, on a virtual machine where a managed identity is connected to that, then it will automatically know to authenticate as that as well, right? So some other useful commands that you might end up using is obviously the get help command. As usually for every PowerShell command, you can use that to view what kind of parameters are available and what's the kind of output you can expect, and show some examples. However, if you want to discover which commands are available, you can use the get commands PowerShell module as well. PowerShell command as well, and then you can just provide it the Microsoft.graph module. You can add the star after that because there are several sub-modules, if we can call them that, over there or from the Microsoft Graph API as well. And if you add that, it will include all of the Microsoft Graph modules, right? And it uses the Microsoft Graph PowerShell module uses the standard PowerShell syntax that you will probably be familiar with. So you provide a verb first and then a noun, right? So you can do some additional filtering on the verb. For instance, the get verb will provide us all of the commandlets where we can retrieve some kind of information, right? Where if we set a noun to user, for instance, with some wildcards, we will retrieve all the commands where we can receive some information or request some information about users, right? Similarly, if you would use the verb set, then you would find all the commandlets where you could modify some properties of a user, right? All right. So these are two PowerShell commands that are available by default in PowerShell, right? But there are also some additional commandlets that do kind of the same thing, but that is part of the Microsoft Graph PowerShell commandlet, Microsoft Graph PowerShell module itself. So if you use the find mg graph commandlet, You will also be able to list all of these commands, but it will also show you all the APIs that it will interact with, right? So also very useful, and it also lists the required permissions, right? So if we let's go do that in the lab. So for instance, let me copy that really quickly. So this will return all the PowerShell commands containing the keyword user in there, right? We can also filter that on the method. So return only the get commands. We will see that it will return all the beta commands over there, but the ones we are mostly going to be using are the production ones. So here you can see the one that we saw previously, get mg user. You can see as part of the users module, you can see which kind of API request it will send in the background as well, which is also very, very useful, right? So if we actually yeah, if you filter this down even more, you will see that we also we will get terrible output over here. But if we scroll up a little bit, you will also see what kind of permissions that we need, and we could go deeper in that to also view that it would have the users .read basic all permission, right? So also something very useful that you can use. The question is, do you need access to a subscription in order to use the Graph PowerShell module, such as with Azure CLI? No, you don't, because the Microsoft Graph PowerShell module, recall as we said previously, is mainly used to interact with Entra ID and Microsoft 365 type services. So it will not allow you to actually view information from Azure resources, right? So subscriptions are actually an Azure terminology. So in Entra ID and things like that, you will not have things like subscriptions. So you don't need a subscription to use the Graph PowerShell module, right? You can use it as any user as long as you are able to grant the consent, right? We also have the find mg graph permission commanded. So let me quickly show that one. Find mg graph permission on the application, and then it will show to it will list all the kinds of permissions that exist for a specific type of resource, right? So in this case, for the application, if we list that, we can see there are a couple of permissions that there are on the application property. So we have read all, read write all, and also policy.read write application configuration. So we can do the same for user. And we can see that there are quite a lot of additional permissions on users. So once again, the ones that we saw previously, there is some additional description over there as well, so that you can see what every type of permission actually entails. So also very useful if you have some kind of an access token with different kind of permissions, and you want to see what these permissions actually do, right? If you just run it without anything, it will just obviously return all the permissions that are available, right? All right, awesome. So, start of KC1. We will, before we go into that, we will take a short break of, let's say, 10 minutes because we lost some time at the start, and then we will start going into some of the labs as well. So we will be back at 17:45. And if there are any questions in the Discord already, feel free to add them over there. All right, so let's continue. So this is the start of the first kill chain, so kill chain 1. We will first cover some theory showing you how a technique works, why it works, what happens in the background, and then we will show you how you can, how we will use this technique and actually apply it in the lab during one of the learning objectives, right? Please try to just follow along with me and just try to understand the material. You will have enough time after the sessions or in between of the sessions to actually test these learning objectives yourself, right? So now it's just important to just watch when we go through it, and you will have enough time to try the learning objectives on your own afterwards, right? Okay, so first thing that we want to cover is device code fishing. And actually let's just start with explaining device code authorization, right? So Microsoft has, or the Enter-ID authentication platform has quite a lot of authentication methods that you can use to actually sign in to Microsoft, right? So you can use your normal username and credentials and multi-factor authentication, but there is also a more alternative authentication flow that most normal users are not aware of, and that's called the device code login flow. Right. So how does that work? So, and why is it actually used? Why does Microsoft actually implement that, and what is it used for? So the main idea behind it was to allow a user to sign in to one specific computer or one specific device that is has limited input. For instance, a smart TV, for instance, if you want to sign into that with your credentials, it would be very inconvenient to have to enter your complete email address as well as your complete password, right? Or, for instance, think of a terminal application such as the MG graph module that we showed previously, but also other types of applications such as the Azure CLI also support device code authentication to make it a little bit easier to authenticate to a different device. And instead of having to provide your username and password in this input constrained device or application, you can enter your credentials on another device where you have access to a keyboard and a mouse, for instance. Instead, just enter a code that is generated by Microsoft on your other device where you have access to sufficient input like a keyboard, right? So we will go over the complete authentication process in a little bit, but basically what happens is that your input constraint device just will provide you a 9-character code, and you have to take that code and enter that on your other device where you actually want to provide or go through the complete authentication process, right? And when you do that, your other device, your input constraint device, will actually be signed in, even though you didn't really provide your username and password there. You did that on the other device. But since you used the code that was generated on the input constraint device, Microsoft can link that back together and allow the input constraint device to sign in with the privileges of the user that signed in on the other device where the code was actually entered, right? It works by going to microsoft.com/device login. I can do that now actually, and then I can show you what that looks like. So if you go to microsoft.com/device login, you will see that this is just a legitimate Microsoft authentication web page. It's on the legitimate domain login.microsoftonline.com, and just asks you to enter a code, right? So where do we get that code? that code is generated on your input constraint device, right? So on your smart TV, for instance. And then afterwards, it will go through the complete authentication process. We'll go into a lot more detail a little bit later when we actually demonstrate this, right? So after entering the code, the user just normal authentication. So it requests their username and password. It might request multi-factor authentication depending on the policies of the organization, and consent is requested if that is needed as well. And once successfully logged in, the other device, the input constraint device, will get an access and refresh token. And as we saw previously, if you have an access token and a refresh token, you can authenticate towards these various APIs as the user, right? So how does this work in the background? So the first step will actually be performed by the input constraint device, right? So step one is actually the device code flow is started on the input constraint device. It will send a request towards the device code endpoint from Microsoft. So it's a specific token endpoint from Microsoft, indicating that it wants to start the device code authentication flow, right? All it needs to provide is either definitely it will always need to provide a client ID, and then depending on the actual API version of the token endpoint that you want to interact with, either a scope if you're interacting with the V2 API endpoint, or a resource if you're interacting with the V1 or the original token endpoint from Microsoft. We'll go into more details later on that, right? So user just provides a client ID and a scope, and sends a request to the device code endpoint, and the Microsoft will then return with a JSON object, but the important information that will be in there is the device code, the user code, and a verification URI. You don't really need that verification URI because it will always be the same in case of Microsoft. It will also always be microsoft.com/device login, as we saw previously, right? So what is this device code and user code? So the device code is actually what the input constraint device will keep polling every couple of seconds. So by default, every 5 seconds. So Microsoft will say you need to pull it every 5 seconds. You can pull it at whichever interval that you want, of course, but Microsoft actually instructs you to use 5 seconds. So you can do that if you want to pull it at a quicker interval or a later interval. Microsoft is not really gonna care, but it just recommends you to pull it every 5 seconds. So this device code is very long. It's I don't know how long it is, but it's fairly long, and it's not really in the normal authentication flow. You will actually not see this. This will completely be hidden from you, and it will just be used in the background by the application where you're trying to sign into, to pull the Microsoft to check if the device code authentication already happened or not, right? The other thing that we get is a user code. So as the name implies, this is actually the code that is intended to be used by the user, right? So this is a fairly short code, so it's 9 characters long, so not that long, all uppercase, and with some so uppercase letters or numbers are in there, and it will be 9 characters long. And the idea is that the user either remembers this code or transfers this code to another device. So it will take that code and use it on the other device, right? Where they have access to a keyboard and a mouse for easier authentication, right? So they go to the verification URI, so microsoft.com/device login. It will always be this. And as we saw previously, it will ask for a code and the user will enter that user code over there, right? So that is set over here. On a computer or mobile phone, doesn't really matter. You enter that code and you go through the complete normal authentication process. So credentials are requested, multi-factor authentication can be performed. So how does the Microsoft actually know what kind of conditional access policies it should apply? So that will be depending on the client ID you enter, right? So if you enter a client ID for instance, the Microsoft Office application, and you have a conditional access policy that requires multi-factor authentication for the Microsoft Office application, then at this step, the user will be prompted for multi-factor authentication as well, right? Okay. And in the background, as we said, the input constraint device will keep polling the token endpoint, and it will keep waiting for until the user has actually authenticated, right? So if the user authenticates on their normal device, if that occurs, then the next poll that the input constraint device does to the token endpoint will actually return an access token and a refresh token, right? The polling will happen with the device code, right? So it's important to know, but yeah, it doesn't really matter that much if you use tools for that. This device code will actually never be visible for you. It's actually the user code that you need to provide to your user, and the device code is just to pull the status of the device code authentication, right? All right, so let's clear all that. So one more time, let's go through it with a nice graph, as you can see over here. So we have our client, so our input constraint device, which will start the authentication flow, right? It will send an API request to the device code endpoint to obtain a device code, a user code, and a verification URI, right? So the only thing that's required to be provided by the input constraint device is the client ID and either a scope or a resource, right? Depending on the API that you use. In this case, we will be using the version 2 API because yeah, that's most tools that you will be using for this, such as GraphSpy, Token Tactics, GraphRunner, will all use the V1 API and will provide a resource, right? So therefore, here we will show it with the V2 API, where you have to provide a scope. We'll go into the differences a little bit later on as well. So the user gets, or the client gets the device code and the user code. As we said, the user code is then transferred to the other device. So we have here the user agent. This is the other device where we do have access to a keyboard and a mouse. So the user code is entered over there by the user and is sent to Microsoft. And at that point, yeah, you will just go through the normal authentication process. So you will be asked for a username and password, multi-factor authentication, and so forth. And if that actually finishes, we will receive on the input constraint device an access token and refresh token, because we will keep pulling the token endpoint to check if the device code flow is already finished or not. So as long as it's not finished, it will just return an error message saying authentication is pending. So this is the most common error message that you will get actually. Authorization is pending, so we will check every 5 seconds until we don't receive an error anymore and we receive an access token and refresh token, hopefully, right? If everything went right. So if you think about this from an attacker mindset, you can probably already see that this is very useful for phishing, right? This is called the device code phishing attack if we abuse this. So what we basically want to do during a device code phishing attack is we request a legitimate device and user code with any client ID that we want. So this can be a client ID for a first-party application, such as Microsoft Office, Microsoft Teams, whatever that we want to get access to. And we can also request our scopes or our resource where we want to get access to. So for instance, this could be some permissions on the Microsoft Graph API, right? Or we could directly request an access token for the Microsoft Teams API, things like that. Anything that we want to get access to, we will generate a device code for that and a user code for that, right? Then we send the verification URI, so that's microsoft.com/device login. We send that to our victim user as well as with the user code, right? And then you're gonna need to be a little bit creative, right? You tell the user, you make up some story that will let the victim user be tricked into filling in the user code on the legitimate Microsoft login website, right? And you're going to have to be a little bit creative with that because the device code or the user code is only valid for 15 minutes. So that's not a lot of time, right? Yeah, the users that monitor their email. Yeah, exactly. Yeah, it's not a lot of time. So you have to be a little bit creative on how you approach this, right? It is a very, very powerful attack, but you have to be a little bit creative of how you actually want to use this, right? So during phishing campaigns that I perform, we have had quite a lot of success with device code phishing. We've actually never failed with this either, right? So things that you can do to make it to make sure that the code will still valid is, for instance, you can use phishing where you call the user and actually pretend to be from the IT support, for instance, and you tell them that they need to perform some action to better secure their account, right? And you just tell them, just go to microsoft.com/device login, make up some story. We're linking your user account to your device to make it more secure. Whatever, make up some story, right? And since it's a legitimate Microsoft website, microsoft.com/device login, they will be inclined to trust you a lot more, right? And if they go over there, you can spell them the code and then let them authenticate. You can even tell them, you don't need to tell me your password, right? Just enter your password. I don't need to know your password, right? Just go through that. And then usually they go through that, right? Another method you can use is, for instance, set up a meeting invite, right? So you, in your pretext, you get the user to trust you a little bit. And you, for instance, find a way to schedule a meeting, a Microsoft Teams meeting with the victim user that you want to target, right? For instance, if it's a company that is selling something, you just reach out to them and say, hey, I'm interested in your product. And can we have a call to discuss some opportunities of collaboration or whatever? And then at the time before the meeting starts, you send them a fake Microsoft Teams meeting invite. And instead of the Microsoft Teams meeting invite, you have the microsoft.com/device login URL on there, as well as the user code that is masked as a meeting code, for instance, right? And they will almost always fall for that if you play it right. And if they do, then you get access to an access token and a refresh token of the victim user, right? We have a question. So if I understand this correctly, it's the device that does the login that needs to pass conditional access, not the device that runs the device login, input constraint device. So no, the conditional access is actually applied at the, so it depends. Okay, so multi-factor authentication, for instance, if the conditional access policy wants you to do multi-factor authentication, then this happens at the user's device, so at your victim device. They'll go through the complete authentication process and satisfy multi-factor authentication. But other types of things that are checked, such as the location of the user, and this is the most important one, as well as the user agent, so the device type, for instance, and the client type will be derived from the user agent header, right? These two things are based on the source of where the code was generated, so from the input constraint device. So what does that mean? That means that if you generate a device code here in step 1 from a public IP address from Russia, for instance, and you have a conditional access policy that blocks all authentication attempts from Russia, just to provide an example, right? Then that will be blocked, right? So always make sure to do some take some OPSEC into consideration and do some reconnaissance previously to know, okay, where is the victim that I want to target is located, right? Set up a VPN, for instance, towards there, and then it will use that location to satisfy the conditional access policies, right? Device compliance and Intune also derived from the input constraint device. Yes, sadly, that is the case indeed. So a very useful thing to block this kind of attack is indeed to require a compliant device. If that is required and you don't allow your users or your CEO to access their emails from their phone, for instance, that is not registered, then this will not work indeed. What time is the meeting today should end? So we have about 1 hour and 20 minutes left over here now. All right. All right, but you'll also always all get access to the recording as well. Okay, so let's move on a little bit. So device code phishing. Yeah, we went through this flow already a couple of times, but basically what happens is you are basically going to be acting as the input constraint device. You are going to be generating the device code and requesting that from the Microsoft Identity Platform, and then you send that to your target user, right? So how can we do that? Right, so there are a couple of ways you can do that. You can use GraphSpy, for instance, but you can also do it manually. You can use other tools like Token Tactics, GraphRunner. There are a lot of tools that allow you to do device code phishing. We will showcase a couple of the tools as well. But first thing that we will be doing is doing it manually, just to show you guys that there is nothing magically happening in the background. And I always recommend that you do it manually, even just one time, so that you know what happens in the background, and afterwards you can use some tools to make it a little bit easier, right? Okay, so from PowerShell, we can use this PowerShell script over here to generate a device code. So the input that we need is a client ID. We can use anything that we want, for instance, Microsoft Office. And after entering the code, you will need to make sure that the client ID that you provide over here is something that is believable for your brief text, right? Because there will be some warning messages when going through the authentication process from the user point of view. We will show that later on. And the application that will be showed to the user will actually be derived from the client ID that we are providing, right? And then there are also some scope that we need to provide. So these are the permissions that we want to get access. For instance, the .default will request all the default permissions for Microsoft Office. And what we can also use is the offline access scope. So this is also a predefined scope. If we provide offline access, then we will also provide receive a refresh token, right? So the grant type is going to be this device code string over here. And the tenant, we can use a tenant name here, or we can just use common, and then it will just use the default tenant that the user will be signing into. So I suggest using that, right? We have a question. Suppose we are using a refresh token to generate the access token. After it generates the access token, the old refresh token should expire. If it is not expiring, who is responsible for the expiration? Identity provider or application team? Let me make sure that I understand your question. So if you generate an access token with the refresh token does not expire there. So you can keep using it and keep generating new access tokens with that for as long as the refresh token is valid for. The refresh token by default, if nothing funny happens, like sessions being revoked and things like that, will only expire when the expiry date actually hits. So by default, only 90 days later. The variable grant type is not used in the request. Doesn't seem like it. It seems like there's a small error indeed in the over here. It should be correct in the manual, in the lab manual, right? This should be in the body over there. That's a good thing that you got that. All right, so the response that we will receive is we will receive a user code and a device code. So as I said, the device code is very, very long, right? So this is just used in the background to pull the actual status of the device code authentication, right? The user code is the one that we need to provide to our target, right? And the verification URI, as I said, is always microsoft.com/device login. So the expiry will also be always 900 seconds, so 15 minutes, right? The interval, see, this is what I meant. So Microsoft actually says you need to pull it every 5 seconds. Yeah, it's a recommendation. You can pull it however you want, but most tools will pull it every 5 seconds. There's not really any use to pull it at any other interval. However, if you're going to pull it manually, which we will show later on, you will probably not be able to do that every 5 seconds. You will just check it after a couple of minutes, right? And there's also some message overlays. This is a very static message, always providing the same kind of instruction. So it just says, go to this URL and enter this code to authenticate, right? All right. So once the user actually went through the authentication process, we need to send this API call, right? So this is the API call that will actually be pulling the authentication attempt, right? So over here, we see that the grant type is used in this case. So it's probably this where we initialize this previous variable already, right? So that's where it will be used. The client ID will be the same as the one where we created the client ID. So to go back on that, so the grant type is actually not required on the initial step because we already are interacting with the device login endpoint, so the device code endpoint over here. So Microsoft already knows that we want to do device code authentication, right? So the grant type will be used later on, right? Okay, so this is where the grant type will actually be used. The client ID will be the same as previously, and this is the code. So this is the device code. So don't swap these two around, otherwise it will not work. The device code is a long random code that will be used to pull the authentication attempt, right? It will just keep sending these pulling requests towards the OAuth authentication endpoint, right? So see over here that we're using the V2 token endpoint, right? So that's why we used a scope previously instead of a resource. And if the authentication is successful, so you will see that if no error message is returned, then we can receive an access token from that as well as a refresh token. Okay. So what are some advantages of device code phishing above regular phishing? So I think it's obvious that the biggest advantage is that we're using a legitimate Microsoft website, right? So we're using microsoft.com/device login. So this is a legitimate Microsoft web page. This means that one, the user will be less suspicious because it's a legitimate Microsoft website, right? Two, the security tools of the target organization will probably not block this, right? Because they will not be blacklisting a legitimate Microsoft login website, right? It's using the login.microsoftonline.com domain name from Microsoft. And in a lot of cases, in a lot of organizations where they also do, for instance, advanced detections using SSL decryption, where they will actually be decrypting the content of the web traffic, will also blacklist all Microsoft domains because that can sometimes cause some issues as well, right? So very low chances that this will be detected by a security tool based on the URL itself, right? We will see later on that there are some techniques how you can detect this type of phishing attack either way, right? But just based on the URL, it's very hard to block that for security tools, and your email will probably not be blocked by spam either. It's also very strong because it bypasses MFA completely, right? So if multi-factor authentication is required, this phishing technique still allows you to gain access to the account of the user. Even better, we get tokens that have a multi-factor authentication claim, so we can access resources that require multi-factor authentication, right? So we can use multiple client IDs, and for that we can use any first-party Microsoft application as well. So the client IDs for my Office applications, such as Microsoft Office, Microsoft Teams, Outlook, and things like that. We can all use that to make our pretext more believable, Azure PowerShell, and more. The resources that are supported. So this is the actual API that we are getting access to. Remember, so the client ID is the client that we are acting to be. So recall our earlier discussion. The client is actually the client application, the desktop application of the browser application that is authenticating. And the resource is the actual API that we want to access, the actual server-side application, right? So the resource, we can request an access token for any resource that we want, for instance, Microsoft Graph, the ARM API, Microsoft Teams, and a lot more, right? When we use first-party client IDs, as well, there will also be no consent that will be required because these are pre-consented applications, right? And we will see a little bit later that there is also a concept called family client applications, where we can just easily switch between these client IDs wherever we see feasible, right? There's also something called dynamic device code phishing. This is used in order to avoid the 15 minutes window that we have, right? So that's the biggest drawback of device code phishing, right? We only have 15 minutes. So 15 minutes is not a lot, but if you have a clever pretext, it's still sufficient, right? However, if you want to solve that, we can use something like dynamic device code phishing. So what does that entail? It basically means that we send a link towards the target user, and this link will sadly not be a legitimate Microsoft website, but it will be a malicious website that we host, right? And as soon as the user visits that link, it will dynamically generate the device code ad hoc. So only at the time that the user visits it, it will generate a new device code and it will show that to the user only then. This means that the 15 minutes window will only start running at this point in time, right? So it will only start when the victim actually already visited the link. However, we lose the fact that we are using a legitimate Microsoft website, right? So we are basically sacrificing some kind of benefits from our actual device code phishing attack for a better lifetime, right? So what type you want to use is up to you, right? If you think that you can set up a website that will and set up some infrastructure that will still bypass the security of your organization and you will not be blocked by email security and things like that, you can use the dynamic device code phishing, right? But if you want to be a little bit more careful and think that you have a good pretext that you can force or trick the victim into filling in the device code within 15 minutes, then you can use the classic device code phishing, right? So the dynamic device code phishing, as you will see later on, I will go over that. There is some infrastructure that you need to set up, right? So as you can see over here in the lab, what we are using is we're using a storage account, right? Where we will be hosting a static website. So a storage account where we will be hosting a static website, and this is where the user will get access to, right? As soon as the user visits that static website that's hosted in our storage account, that website will send an API call towards a function app over here, or an attacker application that will be hosting the course anywhere application that will basically make it possible to send a request to the device code endpoint to obtain the device code and the user code, right? Otherwise, we would be blocked by cross-origin resource sharing header, right? So we are using the course anywhere application to bypass this course header a little bit, right? And then it will return the user code and access the user code and device code back over here. And that will be forwarded towards a function app. And this function app will store the device code locally, and it will return the user code to the user, right? And it will show that over here on the web page, right? So the user code will be stored, will be shown on the web page over here, and there will be instructions below that on how you can go through the device code authentication flow, right, with any pretext that you want. So it will instruct the user to go into microsoft.com/device login and fill in the user code that is dynamically generated on the time that it's needed, right? And in the background, the function app will keep polling the token endpoint to check if the authentication already went through, and if it did, it will store that inside the storage app as well. So it will store the access token and refresh token once the user successfully authenticates inside the storage app. Any phishing scenarios in the exam? I can't go into too much detail on what will be in the exam or what will not be. We have some automations running in the lab that will allow you to play a little bit with the phishing itself, but there will probably not be any type of phishing in the exam required, right? But it's still a very good technique to know because this is very powerful if you do any type of red team engagements or social engineering assessments. It's very, very powerful, right? All right. We will go over the device code authentication flow a little bit later during the learning objectives, but first I want to cover something else that's called a family of client IDs, right? And after that, there will be a learning objective where we will go over the first lab, right? So family of client IDs. So this is a set of Microsoft client applications that are in some way compatible with each other, right? So what does that mean? That means that if you obtain a refresh token for any of these family of client IDs applications, which we often refer to as a family refresh token, you can use that family refresh token to obtain access tokens for any application in that same family of client IDs. So recall previously that this should not be possible due to the OAuth specification, right? This should not have been possible, but Microsoft actually is not following the OAuth specification with this and it's basically used to make it a little bit easier for users that if they just sign in to one application, for instance, on their phone, if they sign into Outlook, for instance, then they don't need to sign in again when they try to access a different client, such as SharePoint or something else. That would be very inconvenient. So that's why Microsoft introduced this family of refresh token or family of client IDs thing in Entra ID, right? So if you are able to obtain a refresh token like this, it's obviously very powerful because that means that we can suddenly obtain access tokens for Office, Microsoft Teams, Microsoft Graph, and all kinds of different clients and resources, right? Even Azure, so the ERM API as well. So currently there's only one family, so one family of client IDs, and these are all first-party Microsoft applications. So all of these are, for instance, included, and there are a lot more. And these are also pre-consented, or almost all of these are already pre-consented. So also very useful that the user will not have to go to consent prompts, right? All right. So as we said, the family refresh token is not bound to a specific client ID or scope. It can be used to obtain access tokens for any other client in the family, right? But keep in mind that you can't really use this for any kind of privilege escalation, right? So if you have an access token for a user that is not a global admin, you certainly can't request scopes that the user doesn't have access to, which should only be available to a global admin, for instance, right? So that is not the case, but you can obtain access tokens for other scopes if you play a little around with the type of clients that you want to access, right? We'll see that a little bit later on as well. So an example to give over here, if you have a refresh token for the ARM API and for the Azure AZ PowerShell client, we can request a refresh token and access token. So with this refresh token for a different resource and client ID. So for instance, a Microsoft Graph resource and the Office client ID. So suddenly we previously only had access to Azure resources, but now we also have access to Office documents, for instance, and information from Entra ID. And even for normal refresh tokens, it's also possible to request different scopes, right? So if you have an access token for a specific client, you will be able to obtain access tokens for different scopes or resources. So for instance, for the Microsoft Graph or the ARM API. However, if they are not family refresh tokens, you will not be able to change the client ID there. All right. So let's go into an example, right? So let's say we do device code phishing and we get an access token for Microsoft Teams that is valid for 1 hour. So we can access anything from Microsoft Teams. Using that access token, we can read Teams messages and Teams messages. We also get a refresh token after device code phishing that's valid for 90 days. So we can use that to obtain a new access token for Microsoft Teams. But because of the Foki abuse, we can also request an access token for different resources, right? Such as SharePoint. We can use the SharePoint client ID, where we can now access documents, delete documents, upload files with malware, do all the things we can do on SharePoint, right? We can request an access token for Outlook, view emails, send emails, create email rules, things like that, or for the Azure, for instance, or Enter ID, right? So depending on what privileges that you have, you can create users, reset credentials of users if you have targeted, for instance, a user with higher privileges, right? And the refresh token, as we said previously, can also be indefinitely refreshed until it is not valid anymore, right? And this is obviously a violation of the OAuth 2 specifications, right? Something to keep in mind as well is that if you use request an access token for the Microsoft Graph resource, for instance, Microsoft graph.microsoft.com with client ID Microsoft Office, you will see that you will receive these scopes, so these permissions, right? So because the Microsoft Office client is already consented these kind of privileges, these scopes actually. So these will be the scopes that will be in your access token if you use the Microsoft Office application. However, if you use the same resource like graph.microsoft.com with a different client ID, for instance, Microsoft Teams, you will see that we will get a different set of permissions, right? I've highlighted some of them. As you can see, for instance, the user.read.all is only available when we request a client ID for Microsoft Office, but the sites.readwrite.all is only available for Microsoft Teams, for instance. So with Foki abuse, we can mix and match a little bit until we get the right permissions that we need in order to do whatever we want, right? If we want to access SharePoint, for instance, we might be able to use the Microsoft Teams client ID because it has sites.readwrite.all, right? If that makes sense. This also violates the OAuth 2 specification, right? So Foki is about client ID or resource. So the family of client ID is actually so the client IDs that we are able to modify, right? So that is what the Foki family refresh tokens allow us to do: modify or request an access token for any other family of client ID application inside this family of client IDs, right? So this is, actually covers a question that was previously asked, right? So regarding defense, it will be the attacker IP address that will be logged in the sign-in logs and attacker's device as well. And the location is also the one from the attacker where conditional access policies will be enforced on, right? So if you look in the sign-in logs, you will not see the legitimate user's IP address, but you will see the attacker's IP address, right? So this is obviously something that you can look at as or is important information to know for a defender, right? So also for an attacker, important to know, because then you can make sure that you use an IP address from the same region of your user, right? So if you're targeting someone for, from example, in a specific state in the US, make sure that you use a proxy or a VPN or whatever to request that device codes from an IP address from that region as well, right? And that will also trick the impossible travel alerts to not trigger as well, right? Or suspicious sign and properties alerts that you also have. Also very useful, this was introduced quite recently. So with that, I mean, last year, this wasn't available yet. But yeah, since the beginning of the year, so it's been there for quite a while now. In the sign-in logs, it will now show the authentication protocol that was used to authenticate. So previously, it would not be able to differentiate a normal sign-in attempt from one with the device code login, right? So now you can do, you can see clearly in the sign-in logs that device code authentication was used during the authentication attempt, right? There will be a specific value showing that. All right, so you can use this to, yeah, obviously trigger an alert, for instance. If you have custom alerts on the sign-in logs, you can create an alert. Your security team can create an alert every time a device code authentication was used to trigger an alert, for instance, because it is not that common in most organizations, right? There are legitimate use cases for it, but it's not that common in most organizations. So you will have to see if this is common in your organization or not, but most of the time it will not be. And since recently, there is also a device code, a new policy that you can, or a new condition that you can apply in conditional access policies based on the authentication flows. So this is also new, starting from the beginning of this year, where you can now actually create a block rule to block device code authentication if you really don't want that to be used, right? So access token acquisition is not logged. Yeah, location-based conditional access policy is also effective, right? If you only allow authentication attempts from the IP address of your organization, right, then you can restrict that to conditional access policies. And since the attacker IP address will be used during the conditional access policy checks, this will also block that. But this is really only for the very strict organizations that go very far in restricting access to their organization, right? We don't see that very often, and I've actually never encountered an organization where they are blocking this already. They only start blocking it after we do an assessment after that, and they see how powerful this technique is, right? Okay, so we are at learning objective 1. Device code authentication will show us Intune compliant. No, it will not be compliant in Intune because it will use the user's the attacker's device, so it will not be compliant. If I reset the password of the user, clear all sessions, would that revoke this token? So if you clear all the sessions, that will revoke all the refresh tokens. And in some cases, also some of the access tokens, but only if continuous access evaluation is in use. But in most cases, that will not be the case, but that is something that was covered in the CARTP course, so I will not go into too much detail of continuous access evaluation. But yeah, if you clear all sessions, that will revoke the refresh tokens. But in most cases, you will still have access to an access token until that expires, right? So very important to be aware of that for the defenders. So learning objective 1, find the target email from all corporation website on this website. So let's actually go over that and actually show you in detail how we will solve this learning objective and get initial access to the target organization, right? All right. So this is actually already showing the dynamic device code fishing. So I was running a little bit ahead in my testing already. So first thing we want to do is go to, come on. This is not where we want to go. We want to go over here. All right. So let's say you do some enumeration and you find a website for the organization that you're targeting. So in our case, all corporation, right? We find this website, we do some enumeration. And after going through the website, after a little bit, we find some email addresses everywhere, right? So we have some email addresses over here that we could contact, but this is not the one that we will be contacting. There are some other pages that are also available. So let's say we go to the working here, also, yeah, in a real assessment for real organization, you will see that they will show quite a lot of email addresses on their website, especially for recruitment purposes, right? Let's say we do some more enumeration and we actually end up over here on the job description page. So there's a job description over there where they're looking for a human resources assistant, right? So in a normal case, you would find this using reconnaissance. That would take a little bit more time, but for the purpose of this lab, we will assume that we already know that, right? So here we find an email address of Thomas L. Wright at allcorporation.onmicrosoft.com. So let's say we want to fish this user, right? In a real assessment, you would be using some kind of you would be using some kind of social engineering, right, to convince this user to go through the device code authentication flow, right? But here we will just send an email to this email address, and we have some automation set up where it is acting as a DOM user and just it will click on the device login URL and fill in the device code of the user, right? So let's actually show that really quickly. All right. So first thing we want to do is generate a device code, right? So remember previously we had a some PowerShell code to do that, right? So we're basically providing a client ID and a scope, and then we're sending a post request towards Microsoft, towards the device code endpoint to request a device code and user code, right? So if we see the output, you can see this provides us a user code and a device code, right? So this user code is the one that we will be sending to the user. And this device code is the one that we will be pulling, right? So let's just, for a second, let's try to pull that really quickly to see what happens, right? So the code is all available. We will see if we do this right now, it will provide us an error message. It will say like authorization is still pending, right? It shows up in red because it will provide a different status code. So PowerShell doesn't really like that, but this is the normal flow, right? It will provide authorization pending as long as the user has not been to the authentication flow, right? We can pull again, we'll see it's still not satisfied, right? So let me actually send an email towards our target user really quickly. So what do we send to user? So we usually send them the verification URL, right? I will do this in a new tab. You will not really be seeing that, but it doesn't really matter. I will just send an email towards this user with the device code or with the user code in there. The automation here is fairly dumb, so just send it the user code and it will do whatever it needs. In a real scenario, you would require a little bit more of social engineering, right? Then we will have to wait a little bit until the user goes through the authentication process. We'll just send out the email. So let's wait it out a little bit. You will see that it might take a while. In the meantime, let me maybe just show you how the device codes, or maybe I'll do that later on. Because it might already be finished. There we go. So the user now went through the phishing process. I will show you how it will look like a little bit later on as well. But now you will see that we will have a token. So we received some tokens. We received an access token, which you can see over here, and a refresh token, right? And you can see over here, it's also a Foki token. So Microsoft will tell you it's a family of client ID token, right? When it's set to 1. Otherwise, this value would not be there, or it would be 0, right? So we get an access token and a refresh token. It also says how long the access token is valid for, and it provides us the scopes that we have access to, right? So remember, we requested the .default scope. So these are all the default permissions that we would be getting when we use the Microsoft Office client ID, which is what we used. If I scroll up a little bit in our request, this is Microsoft Office and the .default scope. You will see that the scope is built from 2 parts. So there are a lot of scopes in there, but each permission will have 2 parts. It will first provide the client ID or the application ID, as well as the specific permission that we have over there. Which application is it logging into? In this case, it's the Microsoft Graph API, right? So that was where we were getting to. This is the application ID of Microsoft Graph, and these are all the permissions that we have on Microsoft Graph, right? All right. So now we would be able to use that access token, right? Let's show you the same thing with another tool, for instance, with GraphSpy, right? So we can run GraphSpy quite easily. So I think it's in the current directory already. So you will see on your VM, GraphSpy will already be installed. You can run it on any type of operating system where Python can be installed. So here we're using it on Windows, but you can also use it on Linux or on Kali Linux or whatever you want, on Mac OS as well. And what it will do is GraphSpy just opens a web browser on the localhost interface port 5000. So let's see that over here. And let's go to that in a tab. This is what GraphSpy looks like, right? So we have some databases. By default, there will only be one database. And what we can do for device code phishing is we can go to the device codes page, and then we can request to generate a refresh token, right? Or a device code, sorry, not a refresh token. That doesn't make any sense. So we can specify any resource or client ID that we want to interact with. So GraphSpy is using the V1 API. So here, note that we are using the resource URI instead of the scope So we're specifically asking to access the Microsoft Graph application with the client ID of Microsoft Office. It comes pre-populated with a lot of Foki client IDs as well, right? So if you select submit, you can see that it will have requested a device code now and a user code from Microsoft, right? So you can see the device code is in here, it's stored in the background, you don't really need that. And now GraphSpy will automatically start polling every 5 seconds. So if you see over here, every 5 seconds, it will say you that it has pulled the status of this code, right? You can see when it's generated and it's valid for 15 minutes by default, right? And the nice thing about GraphSpy is you can generate as much codes as you want and it will automatically pull for you. So you don't need to keep checking if the code is already valid, right? Because GraphSpy will automatically pull this for you in the background, right? So let's now actually show you how it looks like from a user perspective that is being fished, right? So let's say we go to microsoft.com/device login. And you will see that the page asks you to enter a code. So this is fairly new, actually. Previously, it just says enter code. Now it actually also gives you a warning. So this is very, very recent. It wasn't even there last month. So this is very, very new, right? Because Microsoft sees that this is being abused quite a lot, right? The device code authentication. So let's actually copy a code. Let's enter that. So now we're going through it from the perspective of victim, right? So just to show you what it would look like, right? And now we will see that it will prompt you for an account, right? So in most cases, the user will already be signed in, right? So there's an additional advantage of this technique is that the user usually doesn't even need to fill in their credentials, right? Because they are already signed in, right? They can just select their account and go through that if they're recently authenticated, right? But what will it show you? It will show you you're signing into Microsoft Office on another device located in France. So these are the two things that the user will see. So France, in this case, is where the virtual machine of the lab will be running, in this case for my region. So this is the country that it will show. It will also say you're signing into Microsoft Office. So where does it get that? It will get that over here based on the client ID. You will see this is the client ID from Microsoft Office. If it suits our pretext better to let it say Microsoft Teams, for instance, we can make it say Microsoft Teams, right? Is there, when a user tries to log in with device code, is there a way to force multi-factor authentication even if user is already signed in? So this is a question that was being asked. Yes, this is actually possible. I'm not going to go into too much detail, but you can, for instance, in GraphSpy, add this flag, enable this flag, and then it will force the user to perform multi-factor authentication again, right? You might want to use that in some cases where conditional access policies might not request multi-factor authentication for instance, Microsoft Office. So that means that you won't get any multi-factor authentication claims in your access and refresh tokens, right? But maybe if you then use Foki to obtain an access token for a different client, which does require multi-factor authentication, then you won't be able to access it with that access token, right? So it can be useful to force the user into fulfilling MFA, right? So in this case, let's use a different account to sign in over there. So let me actually get me the credentials of a test account. So you'll just be signing in with the attacker credentials over here, just to show you guys what it looks like, right? We'll go through the authentication process. it might prompt you for multi-factor authentication. Here it is not required because it's a lab and we have not set up multi-factor authentication for our attacker user. And then it will give you one more prompt. Are you trying to sign into Microsoft Office? Only continue if you trust the website, but they will not read that. They will just read Microsoft Office. Oh yeah, I'm trying to sign into that. We'll click on continue. And now the attack is done. You'll see you have signed into Microsoft Office on your device. You may now close this window. And at this point, the user is compromised, right? And you will see over here that we actually get an access token. So it will change the status to success. So it will change the status to success over here. And where are the tokens stored? So we will have a refresh token stored in a database over here. We can see which user this is. So we can activate this refresh token. So if you activate the refresh token in GraphSpy, it will use that later on when we refresh an access token. It will also say which device code it's used and what resource it was used and things like that. Then we go to the access tokens page and we see that we receive an access token for this user, right? We can also activate that, right? And we can see the details that are in this access token, right? So if you decode an access token, it is actually just a JSON web token, right? So GraphSpy will show you neatly what is inside of this access token. You can also just base64 decode this middle part because that's just what it is. It's just base64 encoding. And it is signed, of course, so you can just tamper with that. Microsoft has signed that at the end with the signature, so you can tamper with that, but you can see what is in there, right? And what's important to know is, or to see in this access tokens is the authentication methods. Over here, you see only password authentication will be used. So in case multi-factor authentication would be required for an application, we will not be able to use this access token, right? Otherwise, it would also say password and MFA, for instance, or it could say something like FIDO if you do FIDO authentication, right? That would also satisfy multi-factor authentication in most cases. We will see the IP address of the attacker, very important. The agents is the resource that we're accessing. The app display name, so this is the display name of the application ID, so Microsoft Office. The name of the user is in there. Not before this time, it should not be usable. There's also the issued at time and the expiry time, but GraphSpy will automatically show you that in a more convenient to view format. So you can see it's valid for about 1 hour and 30 minutes in this case. It's always a little bit random. It's always more than 1 hour at least. User principal name, and I think that are the most important things to cover, except for the scope, of course, very, very important. These are the permissions that we will get, right? You will see them over here. And in GraphSpy, if you activated an access token, you can also see the details of the access token that you activated here at the site, right? Awesome. So, what do we do with this access token now, right? We can, for instance, in GraphSpy, it will automatically send API calls in the background. So we can, for instance, open the OneDrive of the user, Thomas, but the user doesn't have any license over here. Can you use Outlook, Teams, and so forth? It will not work. Oh, no, this is not the Thomas user, my bad. So the attacker user does not have a SharePoint license. The target user that we targeted will have that either way, right? So let's actually continue with the Thomas user over here, right? So what can we now do with that access token? So we can connect with that to the Microsoft Graph API, right? So if we just stop GraphSpy for a second. GraphPy needs setup in the lab. You need to just run it by going to the GraphPy folder. There will be graphpy.py in there, and if you run it with Python, it should work. If it is not, I recommend to reach out to the lab team, and they can look what is wrong with your specific instance. But I wouldn't be waste any time during the sessions with troubleshooting that right now. Right? Okay. So what can we do? Have we already stored that in a variable? I don't think we have. So we have the access token over here. Come on, access token. It's not using tab complete for some reason. That's fine, we can do it manually. Let's store that in a different variable, so we can use that a little bit. And then we can connect to the Maxwell's Graph API, right? Let's connect to the Maxwell's Graph API. We forgot to copy that token. All right, so now we're connected to the Maxwell's Graph API with this specific access token, right? So let's say we want to enumerate some applications. So let's use this command over here to enumerate the graph commands that are available for the applications. And there are quite a lot of them, but the one that we will be using is the getMG application, right? So we will want to list all the applications that are available in our tenant, right? Takes a while. And there we go. So we see a little bit of the applications that are available over here. For instance, Oracle Geology app, and some other type of applications that we will be wanting to access, right? Let's actually continue. We can also request that just manually, right? So for instance, if you just want to send an API call towards the Maxwell's Graph API, we can do that as well, right? So let's actually send this request. And then we have a list of applications, right? And then for each application, let's do some more stuff. Here. I'm trying to make sense of the noise a little bit, so bear with me for a second. All right. So what we're basically wanting to do over here is we are going to enumerate each application. And for each application that we have, we are going to list some additional information. Why are we doing it with the Graph API? Because it is a little bit annoying to work with the MG Graph PowerShell application, and it doesn't really show us the information that we need. However, it is in there. So what kind of information are we looking for? We are looking for all applications that have the key credential or the password credential attribute set, right? So, so you will see over here, there are some applications where they do not have that set. But here we have one, for instance, with a password credential, right? So this is also a client secret. And then we also have the key credentials. And the key credentials indicates that an application certificate is being used. All right. So we see that the Geology app application, for instance, is using a certificate for authentication, right? So that is what we get out of that. We see there are some other ones as well. So the GIS app, this one as well. So let's actually save that information in a XML file using the export CLI XML command, because we will be using that later on. It's important information. Let's say we find a certificate at a specific point in time. We know that it might be useful it might be used to authenticate as an application, right? All right. So what we will do now is we will actually do some Foki abuse, right? So we will actually want to request an access token for the ARM API, because now we want to access the Azure API, right? So let's first go back a little bit. So we have the tokens variable. There was a refresh token in there. It doesn't like tab complete for some reason, so let's just do it manually. All right, so we have our refresh token over here. There are a lot of tools that we can use to abuse Foki. So one thing that we can do is we can import this into GraphSpy, for instance. Actually, GraphSpy isn't running anymore, so let's use a different tool. Let's use, for instance, Token Tactics. And what we can do is use this refresh token. So the tokens.refresh token to obtain a new refresh token, a new access token. But now we want to refresh to the Azure management, an access token for the Azure Management API, right? So for the Azure Resource Management API. In this case, we're using Token Tactics. It has quite a lot of functions available to automatically use a refresh token and convert that to a different type of access token. If we look now, we have a different access token, right? So we can do a couple of things with that. For instance, if we want to see what type of information is in there, we can use something like jwt.io. To decode that access token, right? So GraphSpy can also do that for you by default, but now we can see what information is in there, right? So we see that the audience now is the management.azure.com API, right? So we can use that to interact with the ARM API, right? So let's connect to Azure with this specific access token using Connect Azure account. It'll take a while. All right. So we are now connected to the ARM API. So first thing we always want to do after that is to run get Azure resource, right? As we showed in the basic version of this course, right? So you will see what kind of resources you have access to, right? And it seems like our user, Thomas, has access to a specific resource or a specific key vault, right? So it has access to the GIS app key vault, right? And let's actually show what kind of privileges we have using the get Azure role assignment command. Is Microsoft providing some information about each client, Foki client ID, or do we need to guess that Microsoft Office is the same in the same family of client IDs as the Azure Resource Management API? So no, it is not documented, by Microsoft. However, there is a very good resource. So if you search for that on GitHub, Home Secure Works, this one, it is very detailed information about family of client IDs, right? And you can see known Foki clients, for instance. You will see a list of all the Foki clients. So not all of them. These are the known ones that we found out or that the researchers found out themselves by testing this out manually, right? But Microsoft does not document that. All right, let's continue. So we have access to a key vault. What privileges do we have? So we have key vault certificates exporter. And also a reader role both on this specific key vault. So we can read the key vault on the management plane, and we also have the key vault certificate exporter permission. Right. So let's actually check which key vaults are available using get easy key vault. All right, let's check what's in there. So we have our one key vault, obviously. Let's get the subscription ID, because we will access that key vault to actually see what kind of permissions we have over that, because we have the key vault certificates exporter permission or role. But what actually does it allow us to do? We can sort of make a guess based on the name of that role, but let's actually verify that, right? So for that, we can use the following. It's all in the lab manual, right? But basically what we're doing is we're requesting this subscription ID, the resource group name of this key vault, right? So this will be exploration, then the vault name, we'll store that all in a variable, and then we will craft a manual API call to list the permissions of this specific key vault, right? Using this API version, if we send a GET request towards that endpoint with our access token, then we get a list of permissions that we have, right? So what kind of permissions do we have? We have reads over default, right, over the management plane. And what data actions do we have? So over the data plane, we have the certificates.read and the secrets.getSecret action, right? So we can get export the secrets of the certificate, right, and export that certificate with these type of permissions, right? But to interact with the key vault API, we need to access the an access token for the key vault API, right? The key vault API, we can't access the key vaults with an ARM access token, right? So we can once again request a different access token with Foki abuse, right? So we could once again use token tactics, but token tactics by default does not have anything to automatically obtain an access token for the key vault API by default, right? You could use GraphSpy, because in GraphSpy you can request custom resources as well. So there are a couple that are predefined in there, but you can provide a URI for the key vault API. But let's not do that. I will just show you a lot of different techniques, so then you can you know what you can do in the future if this is not available for you. You can also do it manually, right? So here, let's do it manually by just sending a request towards the token endpoint from Microsoft. So once again, we're using the V2 token endpoint. So we're providing a scope, in this case, the default scope for the key vault URI, using our previous refresh token And as grant type, you use refresh token to authenticate. And that would provide us a key vault access token, right? It's stored in our key vault variable. So now let's connect to the connect once again towards the Azure module, Azure PowerShell module, but now we will also provide our key vault access token. There we go. So we connect this with our previous ARM access token, but now also with our key vault access token, right? So now we will be able to interact with the key vault API, right? Let's actually list the, so we know that there is, we have the permission to read the certificates. Where was it? So we can read the certificates and export the secrets, so the private key as well. So let's list which certificates are stored in this key vault. We have one certificate that's stored in there. So let's actually export that. There we go. So now we extracted this certificate, right? And how do we know that this is a certificate? Well, it's stored in the key vault as a certificate, right? And we see it's a base64 encoded certificate over there, right? So let's actually validate that as well. So what you can do is convert it first from base64, so it will now be in binary. You will not be able to make sense of that if you read it. A secrets byte. You'll see over here it's just binary data, but let's store that to a PFX file. All right. And if we list our the contents of this directory actually, then we should see that we have the certificate exported in a PFX file. There it is, between all the other tools. Okay. And let's go back to the slides. So this was actually the learning objective one, right? So we used device code phishing to compromise user Thomas. We used the family refresh token for Thomas request and access token for other Microsoft applications, right? Such as the Key Vault API as well, and the ARM API. And then we extracted the keys from the Key Vaults, right? All right, so we have a couple of minutes left, but we will probably go a little bit over time so that we can still cover this at least. So in case you need to leave in 10 minutes, that's fine. But just know that it will be recorded as well, so you can rewatch it as well if you actually really need to leave, right? So JWT assertion. So JWT assertion is allows you to, or let's phrase it differently, from the documentation from Microsoft, the Microsoft Identity Platform allows an application to use its own credentials for authentication anywhere a client secret could be used. So JWT assertion basically allows you to craft your own certificate or your own access token and or your asserted access token, and then sign that with your application certificate. So the certificate stores for the application, right? And then use that to obtain a legitimate access token from the token endpoint, right? So basically anywhere where you can use a client secret to authenticate as an application, you can also use JW2 assertion to obtain an access token using a certificate, right? All right. So if we compromise an application certificate like we did previously, we can sign assertions using the private key that is stored in the certificate, right? So we have a PFX file, we both have the certificate and the private key of this kind of application, right? So the benefit of using certificates over client secrets is that there is a longer expiry time, right? So client secrets can only be valid for maximum 2 years, while a certificate can be valid for quite a lot longer, right? So that is why a lot of organizations will use certificates instead of client secrets, right? So you can use the certificate to authenticate directly using as the application, but an alternative method is to use GWT assertion, right? So in the lab, we will see that there will be a specific role, so the Key Vault GWT officer role for a specific application that allows you to only perform signing using a JWT, right? But it will not allow you to extract the certificate keys, right? So in this specific case, you would, if you would have privileges over a certificate, over a key vault, over a certificate in a key vault mainly, you would not be able to extract that certificate, but you can still use the certificate to sign something, right? And what we can basically do in that specific use case is use JWT assertion, right? So we can create our assertion that will contain some information about the application, let it be signed by the certificate, and send that signed assertion towards Microsoft, towards the token endpoint, and retrieve an access token for the application. Even though we aren't able to export the certificate, if we just have the privileges to sign with the certificate, that still means that we can compromise the application that is using that certificate for authentication, right? Such as we will see in the lab, data analytics app has. All right. So in the app, you will see that there is an application that has read and sign permissions. So the GIS app has read and sign permissions on the data analytics app vault. We will enumerate that in a little bit, right? But it does not have permissions to extract a different certificate, right? But we can still use JW2 assertion, right, to create our own access token, sign that with the certificate stored in the app and the key vault, and you then send that to Microsoft to exchange that signed token for a legitimate access token, right? That is what JWT assertion is. If we are owner of the application, we can regenerate a new secret or a certificate. Yes, you can, but that is something different indeed. All right, because here we are not owner of an application, right? So that is what learning objective 2 is, right? So we will quickly cover that as well now. So for learning objective 2, we need to find out which application we can actually access with the just app vault certificate that we extracted from that key vault, right? So let's do that now in the lab. So recall we have that PFX file from previously. Let's actually store that in a PowerShell variable, right? And now recall previously where we exported a list of all the client applications, right? And all the key vaults or all the we extract a list of all the applications with all the key credentials and password credentials it has, right? So we have a certificate, but we don't really know for what application it is used, right? We can make some assumptions based on the subject over here, right? Because there is also an application named GIS app in the lab, right? However, if we want to be even more sure, we can iterate over all the applications that we extracted previously, so over our XML file. That's why we previously stored that. And find an application where the key credentials.custom key identifier, so key credentials.custom key identifier is equals the thumbprint of our client certificate, right? So the thumbprint is basically a unique identifier that will identify this specific certificate, right? So this means that if this matches the custom key identifier value of an application, that means that this certificate will be used to, is linked to this application and can be used to authenticate as that application, right? So what we can do now is, since we have the PFX file, we can actually authenticate directly with that certificate, right? We could do that, but let's actually do some practice and use the WT assertion technique instead to obtain an access token, right? And to do that, we will first import a specific script that is stored over there. It's called new access token.ps1. We can go look at, take a look at that very quickly. All right. New access token.ps1. Let's edit this one. If you're interested in that, you can go over this blog that you can see over here, where they really go into detail of this. However, we will not cover that in that much detail during this course because it is not that useful for us. Just know that it will be using the GWT assertion technique, right? So you don't really need to understand what it does in that much detail, but it will generate an unsigned JWT, which we can completely customize what information will be in there. Then it will sign that using the private key of our certificate. And then that's signed JWT. It's not really an access token just yet. It's just short of being an access token, but we can use that signed JWT, send that to Microsoft towards the token endpoint with ground type client credentials and client assertion type the JWT bearer. Right? If we do that, we will receive a real access token that we can use for authentication. Right? So that is what this script is doing. Right? So if you're interested in that, you can go take a look at that blog. But for our purpose, it's not that useful to go into that much detail, right? Let's copy this command. So what we're basically doing is calling this new access token function with our certificate, the tenant ID of our target organization, right? The app ID, we also need to know that, of course, to authenticate. So the app ID, we got that over there, right? And then we are going to request an access token for the management.azure.com API, right? And you see that we should have received that over here. We can once again go and decode that in if you can switch tabs for a second. There we go. To see what information is in this access token, and we can see we have a valid access token for management.azure.com. The app ID is our application that we are targeting, right? And aside from that, there is not that much valid information in there. Maybe when it expires, so it is still valid for about 1 hour, as we can see over there. All right, so let's use that access token to connect to the Azure API, right? So we have our access token and the account ID will be the object ID of the application. So we are connected over there and let's see what kind of access we have. So we have access to the data analytics app vault, right? So that's what we said previously in the slides. That was expected. So we get access to the data analytics app vault. So this is a different key vault where what role do we have? Let's actually check that with the cached Azure role assignment. Come on, get Azure role assignment. And that is why I copy paste it. All right. There you go. And we see that we get nothing, right? Even if I type it correctly. So yeah, the get Azure role assignment is not always very correct, even though that we know that we should at least have reader permissions over the key vault, right? Otherwise, we wouldn't be able to see it, right? So what can we do if the PowerShell module doesn't work? We can enumerate it manually, right? So let's do that. So what are we doing over here? We are sending a request towards this is our subscription ID, the resource group, and we're checking for the data analytics app vault. So this application app vault that we know that we have access to. And we are once again listing the permissions on that app vault. So let's list the permissions. We have the read permission on the management plane. As well for the keys, for the vault and the keys. And we have the certificates.read, the keys.read and the keys sign action. So now we see that we do not have the privilege to export the certificate, right? So unlike previously, if we can still find that, it doesn't really matter. Previously, we had the privileges to also export the certificate, right? We had the secrets.read, I think, was the permission that we had. But now this certificate we can't even export, right? So what do we do? It's still possible in this case to use a JWT assertion technique, right? So previously, with the certificate that we had, with the previous application, we would still be able to authenticate with that directly if we wanted to. But we used the JWT assertion technique to show it off already, right? Here, we don't have a choice. We have to use the JWT assertion technique because we can't really extract the private key from the certificate, right? But we can still sign things with this, right? So how do we abuse that? It's still possible with our script. Let me copy the command and then I will tell you. I'll show you. So first we're gonna generate a new access token because the previous one might almost expire already. So now we have a new one. And what we are going to do now is we are going to extract some information from the certificate first manually, right? So we're gonna get information from the data analytics app key vault, right? We're gonna get the certificates. Why can we get that? We have the certificate/read. So we can get information about the certificate, but we cannot extract its private key. So we cannot authenticate with that, right? But we can still read some basic information about that. For instance, over here, the information that's in there that we will need later on, right? And now I'm just going to paste a big blob of PowerShell in here. It's a function that we're going to be using. You don't have to understand any of this, but basically what it will be doing is it will use this access token to send some information towards the key vault, so towards this data analytics app key vault, and sign our JWT assertion with the certificate that is stored in there with the data analytics app cert. Right, so this is what this function is going to be doing a little bit later. Let us do that over there. All right. So we have no, actually I was wrong. That thing that I said we would be doing will happen a little bit later. This will just get some information, certificate details from the key vault that we will still need a little bit later, right? So this is the information that we need. So for instance, the X5T and the kit is what we are going to be needing a little bit later on. Sorry for the confusion about that. Right. Now we are actually going to import the function that will be doing the signing in the background, right? All right. So the new signed WT, let me see, where would today's recording be accessible? So I will post the recording later on in the announcement channel. So the link to the recording will be posted right after the session. However, it may take a couple of hours for Zoom to actually parse that, right? So it will be available in the announcements later on. Right. So this script over here will just take all of the information that we previously extracted and use that to create a signed JWT token, right? So we can see that over here. So once we have that signed JWT token, it's now signed because it's used the credentials of the GIS app application to reach out to the data analytics app vault and sign our unsigned JWT assertion. So this is what we now have. We have our signed JWT, and now we can once again send that to Microsoft to request an access token for the data analytics app vault. Right, and now we have this access token, right? Sorry if it's a little bit confusing to follow, but I'm going to try to go over this as quickly as possible. And now we see that we have our access token for our data analytics app, right? And we can now use that to connect to the key vaults as well. So let's do that in a second. All right. And let's see what kind of permissions we have. So which part of the command use the private key? In this case, none of it, because we don't have the private key, right? The private key is stored in the Azure Key Vault, but we're basically sending a request, an API request to the Azure Key Vault to let it sign it with the private key stored in the Key Vault, because we have the permissions to sign it over here. So we have the keys sign action permission, so we can send a blob of data towards the Azure Key Vault API and let that sign that data for us, right? But we do not have the permission to actually extract the private key, right? So that is what's happening over here. All right, so now we're connected as the data analytics app. So get easy role assignments. We seem to have access to a storage account, right? And what kind of access do we have? Let's run get easy role assignments, and we can see what permissions that we have. So there is one storage account named all data store, as you can see over here in the exploration resource group. And we have the storage blob tag modifier permissions on that. All right. Let's enumerate a little bit more what kind of permissions the storage blob tag modifier actually gives us, right? Because this is a custom role, so let's actually see what are the exact permissions that we have on the storage account all data store, right? So this is the all data store storage account, right? Let's list the permissions, and the exact permissions that we have are the read role assignments.read, storage account.read on the data plane, containers.read on the data plane as well, and on the data plane, so what actual data can we get out of that? We can read the blobs, and we have also a weird permission where we can have the option to write tags, so we can modify tags on that on the blobs in that storage account, right? We also see that there is some kind of condition over here, and this is something that we will cover in the next session, actually, because this was actually already the end of learning objective 2. So what did we do? We found out the application that uses the certificate extracts from the GIS app files. So in this case, it was very obvious. It was the GIS app application, right? Then we used that certificate to craft a JWT assertion for the GIS app and use that to request an access token, right? We could also just have used the certificate in this case, but we were just learning the JWT assertion here, so that's why we didn't do that. Then we enumerated the permissions of the GIS app, and we saw that it had access to the data analytics app vault key vault, right? So there was also a certificate stored, but now we did not have the option to actually extract the private key. So we here it was not even possible to automatically or to extract that private key from that certificate, right? But we did have the sign action, right? So what we did is we constructed a JWT token and then use that to use the privileges of the sign attributes from the GIS app on the data analytics app vault to sign that JWT assertion and send that signed JWT assertion to us Microsoft to obtain an access token for the data analytics app, right? And then we enumerated the resources that the data analytics app can access. So this was the storage account, right? All right. So let's clear that and go to the next slide. So next time we will start with attribute-based access control. If you want, you can already go a little bit further this week through the learning session, the learning objective. So you can run a little bit ahead if you want to. Otherwise, we will just start with this next time, right? So the recording will be made available right after the session. I will post a link in the announcement channel. And there you guys will be able to access it as soon as Zoom has processed that, right? Right, I do see that there are some questions still, so I'm gonna try to cover that a little bit over here still, but if you're interested in that, you can also watch the recording if you really got to go, right? So one of the questions, does enforcing logins from compliant devices and conditional access policies stop device code phishing? So does enforcing requirements of compliant device and conditional access policies stop device code phishing? Yes, it does, right? So that is really a very powerful prevention. However, sadly, not a lot of organizations require that, right? Usually they use compliant device status only to not require MFA, right? So usually they're like, oh, if you're using a compliant device or if you're connecting from the company IP address, from a company location or from a company VPN, then you don't need to do MFA. And if you don't connect from a compliant device, you need to do MFA. But usually they don't block access based on that. There are a couple of organizations that I have encountered there. And then it will stop that, right? But then it's still not the end of the world, because if you are good in social engineering, you can, this is something real that happened during assessments. We saw that this organization had very, very strict conditional access policies set up, right? And we were not able to perform device code phishing because conditional access was blocking them. So we our pretext was so good that they felt that we were able to make them believe that the issue was at their side. So we told them there is a misconfiguration in your conditional access policies that you need to fix in order to allow access to this resource, right? And they sent that to their IT team, and 10 people from their IT team looked into that, and they couldn't find the misconfiguration. So they just created a temporary exclusion in conditional access, and we were able to do device code phishing afterwards, right? So if you have a good pretext, you can get around that, right? But otherwise, it would stop that, right? Could the victim get the code from the compliant desktop and just log in? It would just prevent phishing if, for example, they try to log in with their phone that isn't compliant, right? So yeah, that I covered that with the previous thing already, right? Would it also work with something like a FIDO2 hardware key? Yes, it definitely is possible to do device code phishing with FIDO2 hardware keys, because you're only interacting with the legitimate Microsoft login token endpoint, right? So if you use device code authentication and the user actually uses a FIDO key, they will actually be authenticated, and then you will receive an access token even with the FIDO claims in there, right? So very powerful. Also, are you going to change the slides later and add more? I might add some additional things in the slides, but in general, it will be the same content. I just might add some clarifications here and there where we see that it's needed, right? But overall, we shouldn't change it that much. But if something changes, we will also let that know in the announcements channel, right? How do you know if the certificate is being used for authentication in order to sign a JWT token? So how do you know that certificate is being used? So that is what we enumerated previously. If I scroll up a little bit. So that's what we enumerated over here, right? So recall that we extracted a list of all the applications from the old corporation tenant, and we stored that in this XML file, right? So what we basically did afterwards, we searched all applications and we filtered them on trying to find the application where the custom key identifier matches the thumbprint of the certificate that we just have, right? So if we see that key credentials object is in use for an application, we know that that there is a certificate linked to that application, right? And that certificate will always be used, can also always be used for authentication, right? So then if we have a certificate, we can use this technique to find which specific application our certificate will be used for. Usually you can already see it from the subject, but if we want to be really sure, we can check the thumbprint, and if that matches the thumbprint stored here in the application, then we can find that, right? That answers your question. All right. Any other questions so far? In case you have any questions during the coming days, just post them in Discord, try to help each other, but I will always also be available in Discord, and I will try to help you guys as well, or reach out to AltSec admin on Discord as well, or you can reach out towards the lab team using the azadvanced@altasecurity.com email address for support with the lab and questions as well, right? All right, awesome. So if there are no questions at this point in time, we will conclude the first session over here, and we will continue next week.